Hi, I Dr. Prashant Padhyay welcome you all once again on my YouTube channel Gate Arena. In today's lecture, we will going to talk about some of the transistor terminal. In transistor, we have seen that it has got three terminals. When we are talking about these three terminals, so we are drawing these three terminals. So let's say I'm talking about a transistor as a NPN transistor. So I'm writing N, P, N transistor, or I can write a PNP transistor. So I'm writing here PNP transistor. And what we have discussed till now is that each section of these transistors are being doped by a semiconductor. Or we can say the three sections of transistor are doped. That means we will be using the different types of impurities for these transistor. So basically, when we are talking about these transistor, we have got the naming for this transistor. So generally, we say that we have got a ammeter. So the this one we are saying as a ammeter, and this one we are saying as a base, and this one we are saying as a collector. And similarly, when we are talking about the PNP transistor, again, we are talking about this as a ammeter, this as a base, and third one is my collector. So basically, we can say that when we are talking about the transistor, we have got a three terminals in a transistor, and they are your ammeter, base, and collector. Whether you are talking about the NPN transistor or you are talking about the PNP transistor. So first, we will going to talk about the ammeter. So I'm writing here. First, I'm talking with respect to the ammeter. So as we have seen that whether it is a NPN transistor or PNP transistor, ammeter will be ammeter only. Okay. So we say that this ammeter is responsible for supplying the charge carrier. So I can say this is responsible for charge carrier. Okay. So this is responsible for the charge carrier, and the charge carrier can be your electrons, or it can be your holes. Okay, depending upon the type of a transistor you are using, whether you are using the NPN transistor or you are using a PNP transistor. So another important thing about this ammeter is that this ammeter is always forward biased. So I'm writing forward biased with respect to base. Okay, and I will going to highlight, because this is very important property, that this ammeter will always be forward biased with respect to your base. Okay, that means whether we are talking with respect to the NPN transistor or whether we are talking with respect to the PNP transistor. Okay, we always say that this ammeter will be always forward biased with respect to the base, and the reason for this is so that it can supply a large number of majority charge carrier. Okay, so why we are saying that it should always be forward biased, so that it can supply a large number of majority charge carrier. Okay, so again, the majority charge carrier will going to depend upon whether you are using the NPN transistor or you are using the PNP transistor. So the majority charge carrier again will going to depend, this majority charge carrier will again going to depend on the electrons or holes. Okay, that if we are talking about the N type semiconductor, then electrons are the majority charge carrier. If we are talking about the p type semiconductor, we say holes are the majority charge carrier. Let's consider the example of it. So let's say if I'm talking about this NPN transistor, so let me draw this NPN transistor. So I'm writing here NPN transistor. And now what I'm doing is that I'm saying that I want to make this ammeter. So I'm writing now here a ammeter, and here I'm writing a base, and I'm writing the C for collector. So I'm writing here E, B, and C. So I'm writing ammeter base collector. And now what I'm saying is that I want to make this ammeter and a base. So basically, if you remember, we are talking with respect to this junction J1, and we are talking with respect to this junction J2. So now I'm saying that J1 junction, I want to make this J1 junction to be a forward biased. Okay, so what I will be doing, since it is a N type, okay, so I will going to supply a negative. I will going to connect this N to the negative terminal of the battery, and this will going to become my forward bias. Okay, and again, I want to make this J2 as a reverse bias. So what I can do is that I will going to connect this N to the positive side of a battery, and then I will going to say that it will going to become my reverse bias. Again, I am writing that point junction J1. Okay, I'm writing in bracket J1 is always forward biased between base and ammeter. So I'm writing it as a B E. Second, I'm saying is that junction J2 is always reverse biased between collector and base. Between collector and base. So I'm writing it as a CB. So what I'm saying that I want to make this as always as a forward biased, and I will going to make it as a reverse bias. And if I take an example of a PNP transistor, so let me take an example of a PNP transistor. So here I'm making a P and P transistor. So again, I have to talk about this junction. So I'm talking about this junction J1 and this junction J2. So what I have to do, I have to make this junction as a J1 as a forward. So this is a P. So I have to make it connect to the positive terminal of a battery. So it will going to make it as a forward bias, and this P, okay, I want to make this J2 as a reverse bias. So I will be connecting this P terminal to the negative of a terminal of a battery. Okay, so this will be my forward biased, and this will be my reverse bias. So moving ahead, we have got another terminal. So let me draw it here again. Okay, so let's say I'm writing here N P N, or I will be talking about P and P. And for the just for the sake of convenience, I am writing this is a ammeter. So this is my ammeter. This is my base. So I'm writing this is my base, and this is my collector. So this is my collector. Whatever the configuration you are using, okay, whether it is an NPN transistor or PNP transistor, you will be having the ammeter base and collector. Now, again, since we have already seen that we will be talking about these junctions, so we will be having this J1 junction and J2 junction. Here also we will be having a J1 junction, and we will be having a J2 junction. So I'm writing here that our purpose is to make J1 as a forward bias and J2 as a reverse bias. Okay, so we have already seen in a previous slide that we have talked about the emitter, that this is the emitter is responsible for the charge carrier. Okay, so the charge carrier can be your electron on holes, so it will always be a forward biased, and when it is been forward biased, it will going to supply free electron to its junction with the base. Now second we have got a collector. So the second one we have got a collector. So now we are talking about the collector. So when we are talking about the collector, so the collector is being used to collect the charge. So I'm writing here that the collector are being used to collect the charges, and therefore it is being given the name as a collector. For example, just to make it more simple, you can take an example of a ticket collector which is being available at the railway station or in trains. So you can say that the purpose of the ticket collector is to collect the ticket. Similarly, when we are talking about this collector, the purpose of this collector is to collect the charges that are coming from the base. So this is the base. Okay, whatever the charges are coming from emitter to the base and from the base to the collector, then this collector will going to collect all these charges. And the collector is always reverse biased. Okay, I'm highlighting this, that the collector is always reverse biased. And why it is been reverse biased? So we have got a reason for it. So I'm writing the reason for it. The reason of collector, or we can say this base and collector to be a reverse bias, is that basically its function is to remove the charges from its junction with the base. So what we are saying, its function is to remove charges from its junction with the base. For example, if we talk about the collector, okay, so in first diagram we have got a collector. So in this we have got a collector as a N type, and in another one we have got a collector P type. Okay, so for example, if I'm talking with respect to the P and P, okay, so we are saying that this collector C, okay, that means I'm talking with respect to the PNP transistor, okay, has a reverse bias, and this will going to receive whole charges, whole charges that flow in the output circuit. Whereas when we are talking about NPN transistor, so what we can say is that this is the collector C. Okay, that is, I'm talking about the N type. So NPN transistor has a reverse bias, and it will going to receive electrons that flow in the output circuit. I hope this is clear to you that what is the collector is doing. So it is collecting the charges, whether it is your hole or whether it is your electron. And then finally, we have got a third terminal, which is known as the base. So I'm writing here base. Okay. Now, when we are talking about this base, what we say, this base is the middle section, as you can see that whether I am talking about the NPN transistor or PNP transistor, this B is my middle layer. Okay, so we can say that this is the middle section. This is the middle section which is formed by two PN junction. okay, between emitter and collector. And this base is responsible for making the base emitter, that is junction J1, as a forward biased and base collector as a reverse bias. Okay, so I'm writing this. The base emitter is forward biased, and when we are talking about the forward bias, we are saying that it will allow low resistance for the emitter circuit. Okay, and when we are talking about the base collector, so I'm talking about the base collector. That means we are talking with respect to this junction J2. Base collector junction is always reverse bias, and when we are saying it is a reverse bias, we say it provides high resistance in the collector region or collector circuit.